Hey Shane,
Hey there, how are you?
I'm good, thanks yourself.
I'm good. So, yeah, tell me where you're at and everything. You are taking your test. When are you taking it?
I'm thinking of taking next month. Um,
June?
so yeah, June, I think it's June 27th, about.
Okay. Have you taken this test before?
Yes, I have, and I bombed it. Um,
When was it?
I took that last year. I think it was still May.
May
Uh,
20.
yeah,
And how did you do?
I was at 490, 494 there about.
494. Do you remember like roughly what that breakdown was?
One second, let me look.
Sure.
How's the day going?
Going pretty well. I like to trade stocks, and so today was a really good day in that world because of Trump's trade negotiations with China. How's your day?
Good, good. Just working from home today.
Just what?
I'm working from home today.
Got it. What's your like job that you work from home?
I work with U of A, so I just moved to from California to Arizona
Yeah.
because of all this
Oh,
medical stuff. So I work with family and community medicine. So
you
there's a
said
lot.
you're working at University of Arizona.
Arizona, yeah,
Got it.
yeah. So there's a.
What do you do for them?
I work in administration. So the reason I decided to move all the way from California down here was because the doctors in-house, so I don't have to struggle with shadow. So
Mm-hmm.
it's a research facility, so a bunch of research going on if I wanted to do that. And they have a mobile clinic that goes out to help uninsured people in the community. So I can just hop on there to like, those kind of stuff that, medical pre-med struggle to find. It's just
Yeah.
right. All I have to do is just make a phone call. I'll
Got
be
it.
with you guys tomorrow. So
Got
that
it.
makes it a little bit easier for me. So that's why I decided to make the move down here. Oh, if I can find this stuff.
Mm-hmm.
So, but while we talk about that, okay, I think I found it with my scores. Scores. Oh, it was actually 492. So,
Okay.
uh, 122, 122, 123, 125.
Sorry, tell me that breakdown again.
122, 122, 123, 125.
Got it. So, and when you took this, like, did you take any like practice tests?
I did. I was, the actual exam scores that I got was actually reflective of what I've been getting over my practice test. Um, I
Yeah.
think my fundamental problem is just to be able to understand the text itself. Um, my psych soc is still current, like the 125 I got here is still like the same thing I'm getting now in my practice test, which is like 126, 127.
Which practice tests have you taken?
I've taken a blueprint. I did the 6 and 7.
You did blueprint
Six
test
and seven. Yeah.
6 and 7. Any reason you did those in particular?
Yeah, because those I did previous ones earlier
Oh, so
last
you
year.
did.
I didn't want to like take the whole thing all over again. So I just wanted to like take something different that I haven't taken before.
So you took blueprint full length 1 through 5 before.
Yeah.
So wait, when did you take? Because yeah. When did you take the? So you took the MCAT once before.
Yes, I have.
Okay, and that was the one in May of last year.
That's right.
So blueprints full lengths 1 through 5. When did you take those?
I took those when I was studying for the real thing prior
That was
to,
last year?
yeah. So I didn't want to like because I thought I could remember and just like pick those answers, especially when I get to those passages. I just like it's better I just start somewhere different.
So you
Um,
took blueprint full length 1 through 4 for your test in May of
yeah,
2024. And then
I
you
think.
took blueprint 6 and 7 now.
Mhm.
Got it. And um is like the price is like the score range the same?
I think I did. I got a 497 on the practice test six, and I did worse because I did worse the second one because I did a
Yeah.
whole lot of things going on personal life wise. But I saw a pretty good improvement in my scores for practice test six, which was a 497.
Okay. And how was 7? Test 7?
Oh, sorry. I think it was I took five. That was the 497, and the six was the 491. Actually, I wanted to skip that exam because my mental health was somewhere else. I
Got
was
it,
like,
got it.
just gonna like just get this through, get this over with, instead of
So,
feeling happy.
okay. Have you taken any of the AMC full lengths?
Um, I took the sample one when I was about to take the video.
And when did you take the AMC full length sample?
That was back before I took the original one. That was last year.
Okay.
Yeah, that was the only one I took so far.
What about the other AMC content like the CARS question pack, diagnostic tool, and the AMC section banks?
Yeah, I've been playing with those a little bit, here and there.
Hmm.
UWorld. Um,
You said UWorld as well?
yeah, I use UWorld. I'm actually using Blueprint as well. Blueprint, like
Hmm.
the full course itself, but I'm still struggling.
Got it. Okay.
A ton of your videos since last year. You know, the email I sent you, that was like since last year. So that was back in 24.
What
When
were you saying about back in 2024?
yeah, the email I sent you, that was back in 24.
Oh my God, I see it now. I didn't even notice that.
Yeah, that was back in
Yeah,
24.
May 19th, 2024. Got it. Got it. Yeah.
Who knows? If you had responded probably by now, I
Hmm.
would have done better.
Yeah. Got it. Yeah, I apologize for that. I don't know what happened.
You're busy.
Okay. So let's see. Okay, so your te we have well, I guess we have 1 month, a little bit more than.
Mhm.
Um, okay. So we're gonna have you do let's have you do like the AMC full length. So I'm gonna have you start off with the Jack Westin content diagnostic.
Okay.
That way we get to quickly see what type of content um gaps that you have that we can fix. Let me start putting together a schedule here. Are you how much are you like working?
I have a full time, so um, Mondays through Fridays,
9 to 5,
probably 8 to 5.
8 to 5?
Yeah, yeah, it takes me an
Yeah.
30 minutes to get to work and back. So
And you're totally set on taking it on the state?
um, I'm hoping on applying this cycle.
Yeah.
So depending on how much I improve,
Yeah.
I don't mind pushing it back, but I'm definitely set on applying this cycle.
Got it. Yeah, because if you're applying this
Mhm.
cycle, yeah, because if you're applying this cycle, um, you know, you would want to take it sooner, but also, you want to get the highest score that you can get. So, we want to see if that could be possible by that point. Um, and like I usually have students, start preparing like, maybe like 2 months in advance at least. So, but yeah, we're gonna try to have you prepared by the 27th of June. So let me share my screen here. Let me know if you can see it.
Yes.
Okay, so this is going to be your MCAT date, and we're going to aim for you to do a full length, like an AAMC full length, let's say like, each weekend. So that means 1, 2, 3, 4, 5, and then 6 if we get, well, actually, you took the sample before, so there's 5 left. So maybe if we start next weekend, we can get all the AAMC tests down. Now, what I want you to start off with, so like you're using Anki already, right?
Yeah, every day. Apart from
Okay.
today, I haven't done it so far today, man.
Yeah, so with Anki, like I don't really care about like how many cards you do because that can take really long. I care about uh how much you're doing in terms of time. So you can see here I wrote for Anki 45 minutes to an hour.
Okay.
And now I'm gonna adjust this to say Jack Westin content diagnostic. So how to reach that, you go to the Jack Westin website and it looks like this. And you scroll down to the QBank here, hit study QBank now. And then here it says MCAT content diagnostic, right over here. So select that. And then there's one for BB, one for CP, one for Psych Soc. So these are only they're not going to be passage based. They're just going to be discrete questions.
Okay.
But there'll be questions that cover every topic on the MCAT. So this will be a great way to figure out, what content areas you're strong in, what content areas you're weak in. So we're going to have you start with that. And so I'll put that here. And then for cars, you're going to have the AAMC cars question pack volume 1, volume 2. And so maybe I'll write down in the notes section here the content, the stuff that you should have. So from AAMC could be cars question pack volume 1, volume 2, AAMC cars diagnostic tool, AAMC section bank volume 1, volume 2. The section bank is going to be broken into the science sections, so like a CP, a BB, and a Psych Soc. And so we'll start you off with Anki, of course. I mean, like that's going to be something that you do every day. And the Jack Westin content diagnostic and cars, like either AAMC or Jack Westin cars. And
Mhm.
we'll have you do this for basically like this week, like I'll give you until like next Friday
Okay.
to do this. So this means that you'll do the Jack Westin content diagnostic in addition to reviewing the con the content diagnostic, and we're gonna go over some of that together, like whatever doesn't make sense even after you read the solution, we can go over when we meet.
Okay.
And for each of these days, like I'm going to share this with you, of course, but for each of these days, whatever you do, just put a strike through like that. So like, and if you do something different, like let's say you were only able to do 30 minutes of Anki, you could just edit the cell to say 30 minutes and then you can put the strike through. But basically, you're going to be doing, so again, Jack Westin content diagnostic is here, right? You know how to access that?
Yeah, yeah, I'm actually on it right now. Just looking at it.
Good, good, good. So we're gonna have you do that, and we're gonna have you do some cars practice. Um, and like, we'll go over like a cars strategy together. Maybe today, maybe sometime this week, but that way, like sooner better than later, because I want you to start using the cars strategy. As you continue to do cars practice. Um, and yeah, so I'm basically giving you like until next Friday to finish up this Jack Weston content diagnostic, which means finishing up reviewing it as well as doing some cars practice every day. And then on the 24th, we'll have you take the AAMC scored pre-exam first. And so how I have this set up is that so like on the 24th, you're gonna do the exam like you would do it normally, timed and everything.
Yeah.
And then when you're done, you get your score and then you're done for the day. And then on the Sunday, you'll do something called a blind review followed by a regular review. So now what the blind review is let's say for the CP section, you have 15 questions wrong. What you're going to do is the premise here is that you could get questions wrong because you really didn't understand them, but you could also get questions wrong because you're running out of time. So we want to separate the two because if you just looked at the solutions for questions that you got wrong because you were running out of time that you otherwise could have gotten right, you would be kind of wasting those questions, right? If you just look at the answers. So
Yeah.
let's say for CP, you have 15 questions wrong. You're going to write down what those 15 questions are. You're going to try not to look at the answer. You're going to start a new attempt at the test, this time without the time limit, without the time constraint. And you're only going to try these 15 questions you got wrong the first time. That includes questions that you got right by guessing. So essentially, the questions you got wrong, you're going to try them again without the time constraint. That way, we can see that, hey, there's some questions that you understand, but you got it wrong just because you're running out of time. Does that make sense?
Yeah, that makes sense. Yeah.
So let's say, so you do your blind review for the 15 questions you got wrong. And let's say now 7 questions are wrong, which means like 8 of them you understood. For the ones that you got wrong after your blind review, then you'll do a regular review, which means you're reading the solution. And if it makes sense, you're good. If it doesn't, let's say 3 of them are left that still don't make sense, even after you read the solutions. We meet, we can focus on these 3 rather than going over all 15,
That makes sense.
right?
Yeah.
And it doesn't mean we always have to do that. There could even be questions that you got right, but if you're curious how I would approach it, we can go over that as well.
Okay.
But this way we get to make the most out of the practice tests that we have.
Mm.
And now in between the practice tests, like let's say on this practice test you got questions on like titration and buoyant force wrong, then during the week we'll have you do UWorld. I call it targeted content, meaning again, if on this test you get like titration problems wrong, during the week, you'll be doing UWorld problems on that topic. So you'll be doing UWorld problems on titration, right?
That makes
Um,
sense.
yep. And then you'll be doing like some cars as well. Um, and yeah, I can say like AAMC slash Jack Westin cars, and this could be for the rest of this week. And then you'll be doing AMC full length one. Let me update that. Full length one. And then again, it'll be the UWorld targeted review. and then AAMC full length 2, and the targeted review, and then AAMC full length 3, and then lastly, AAMC full length 4. Now, around this time, because we also want to make a goal of finishing up the AAMC material, like the section banks,
Yeah.
I would say like let's aim to like, you probably aren't going to be able to finish all of UWorld, but let's aim to finish as much of it as, and I mean the sciences, not cars. For cars, we're only going to be using either Jack Westin or AAMC. But for the sciences for UWorld, we're going to aim to have you try to do as many, like, cover as many of them as possible so that by the 16th, or maybe we could even start like, let's say on the 11th, we're going to have you start to focus purely on AAMC. So AAMC section banks, and for cars, just AAMC cars. And I'll put that in for here. Oh yeah, I call that phase 3. And we should finish all of that up by like, let's say the 25th, and then like the 25th and 26th, we're gonna just have like, more of like chill days where you kind of just do passive review like Anki and kind of going over like some notes.
Yeah.
But for the most part, that's what you'll do. So for instance, tomorrow you'll do 45 minutes to an hour of Anki. You'll start, or you could even start it today, but yeah, you could start it tomorrow also. You have the Jack Westin content diagnostic, and you'll be doing either AAMC or Jack Westin cars. And you'll be doing that for a little over a week. And that'll include reviewing it as well to make sure that all the stuff you got wrong, like, that's the content stuff that you want to brush up on. And also in the spreadsheet, I have the content outlines in tabs. Like I took the AAMC content outline for CP, BB, Psych Soc, and I just put them all in this spreadsheet form so that you can like look up exactly what you need to know, and you can use the drop down menu to indicate how well you know that topic. So this is like, exactly from the AAMC. So this is like officially what you need to know.
Okay.
Um, and and then we'll be putting in your full lengths here. So let me just erase it from the other student. But yeah, we're gonna have you start with this free scored one, and then 1, 2, 3, and 4. So we'll be inputting, the dates and the scores that you got there. And there's also some other things here, like, maybe some questions you got wrong that you want to like, analyze. You could do that here. And there's also some of the stuff from like this other student that I have that I guess you don't really need, but whatever. I just have them there anyway, like because the student used them to like review his test. But yeah, for the most part, that's pretty much the setup. So what do you think? What do you think?
That looks pretty nice. Yeah.
Okay. So yeah, I
Something,
just add,
something
yep.
I was going through on Blueprint, but
Yeah, yeah. So I mean, like if we had more time, like what I usually do is I have students after the content diagnostic from Jack Westin, I have students do like either Blueprint or Altius full lengths for phase 2, and then the AAMC full lengths last. But since we only have like 7 weeks,
yeah.
or like 6 weeks rather, um, and there's 5 AAMC tests remaining for you to do, we're gonna have you do the AAMC tests instead. Okay.
That sounds good.
Yep. And so yeah, I have it. So yeah, I just shared that with you. And there's also a Shane MCAT shared drive with a lot of good stuff. So I'm gonna add you to that as well. So like in this shared drive, you can see in like the PDFs folder, I have a lot of like, notes and, things about all sorts of stuff like MCAT math and like metabolism and, all sorts of stuff. Like here's a document where I put them all in like the same cell because I didn't really find anything else that put them all in the same cell. But this way, you get to pay attention to like where in the cell these metabolic processes are happening. You get to see like what the irreversible steps are, and all of that stuff. So this is going to be useful for you to like look through. I have like an optics table. I have all sorts of stuff. So I just added you to this too, so you should have access. Yep. So aside from that, what would you like to work on today?
Um, so my weakest section is, of
Yep.
course, phase.
Oh, I thought you were saying, so you said your weakest section is Chem Phys?
Yes.
Okay.
Psych self, I can pretty much just do Anki on that. My score has been pretty much consistent.
All right.
125, 126, 127.
Mm-hmm.
I definitely want to improve,
Yep.
but I want to focus on my weakest section, which is Chem Phys and CARS.
Got it.
And I'm by it.
Got it. Got it. So, okay, yeah. So when you do your content like, sorry, the Jack Westin content diagnostic, like you'll be, part of that will be doing the CP one where you'll be doing like all the problems and, learning the content and stuff.
Yeah.
Uh, but until then, is there any like particular topics or passages or, concepts in that section that you find to be troubling that we can kind of like go over?
Most of the things, the one I really find I'm really struggling with
Yeah.
is optics,
Optics. Okay. Yep.
lenses, and all of that. So that's the one I'm really struggling with.
Got it.
And also some calculations too, because
Mm-hmm.
I don't really know much about it. I mean, I look at, if it's really, if they give you like the equation in a straightforward way, I can just like plug in the numbers. But sometimes, like, thinking this through before you get to plug in the equations through can, seem a
Yeah,
little
yeah.
difficult.
You definitely want to get into the habit of solving things algebraically.
Yeah.
Um, either before you plug in the values, or a lot of times they won't even ask you or give you values. So okay, maybe we can kind of cover some of those topics. I can open up like a whiteboard. So let's see. Um, Optics. So let's see. Okay, so if we have, let's see. Okay, so let's just here. So I'll write like optics. All right, now I'll start with a plane mirror, which is just a flat mirror. And let's say this is you, and you're a distance of x from the mirror. You will see also a distance of x as if it's inside the mirror. You will see your reflection. Okay.
Yeah.
Now, we need to make a distinction between a real image and a virtual image. Okay. So let's imagine, like what a laser pointer like is.
Yeah. Yeah.
So let's imagine we have a laser pointer here, and it's this, let's say it's like a red laser, and it shoots a laser like at the mirror, and it, bounces off, and let's just say that there's like a wall behind you. The laser light will hit that wall behind you. Okay. Now, there's actually photons that are coming from the laser bouncing off of the mirror and then hitting the wall behind you. Like that's actually composed of photons. Whereas in your reflection here, you would see a reflection of the laser and it hitting the wall behind you, except the mirror's reflection, all of this stuff to the right, is not a real image. It's a virtual image. So a real image is one that can be projected, whereas a virtual image cannot be projected because it's not like real. It's something you can only see from one side. So for instance, right, um let's say that this is an eyeball
Mhm.
that's on this side of the mirror, right? The
Yeah.
eyeball can see that real image of the laser, right? Now let's imagine the eyeball is on this side of the mirror. The eyeball can see this virtual reflection over here, and if if he turns around, can see this real image over here, right? So the
Yeah.
real image over here, I'll just write real image. Both this person and this person can see that real image. Okay. But to see the virtual image, aka the reflection in this mirror, you can only see it if you are on the opposite side of the mirror. Okay. So that's the first distinction we have to make. We have to make a distinction between a real image and a virtual image. Okay. So if you imagine like let's see, do you have like a watch or something that you wear?
Yeah.
Let me see it.
It's an Apple Watch.
Now, do you ever like let's say like you have like some light coming in and it bounces off
Yeah.
the watch and then it hits something else?
Yeah. Yeah. That makes sense.
So
Yeah.
that's so that so the light hits the your watch and bounces off, and where it bounces off and let's say it just like hits a wall or something like that, you could
Mhm.
see that image without looking at your watch, right?
That is true.
But now imagine if you look at your watch and you see and like the screen is like off or whatever and you see your own reflection.
Mhm.
That's something you can only see if you look at the watch, right?
Yeah.
But if you are like if the watch is pointing this way and you're not looking at it, you can't see your own reflection in it, right? But you could see the light that can bounce off and hit something else, right? So that's the difference between a real image and a virtual image. A virtual image is like when you it's like the reflection you see in a mirror or like if you see or like in your watch or like even in your phone, right? If your
Mhm.
phone screen is off, it's like a black mirror, right? And you can see your own reflection in it,
Yeah.
but you can only see it if you're in front of it. If I
Right.
like this, I can't see it,
Mhm.
right? So that's a virtual image. But if the light actually bounces off of that and hits something else, you can see it without having to look into the mirror or the screen, right?
Yeah.
So that's the difference between a real image and a virtual image, okay? And another definition is that a real image can be projected. So, like in a movie theater, the projector, right?
Mhm.
Shoots light out and projects the image on a screen, and it appears like it's a real image because it is a real image. So, uh, which also means that you can treat a real image as an object for a different lens. Okay? So that's the difference between a real image and a virtual image. Okay? So this example I gave is called a plane mirror. I'll write plane mirror, meaning it's flat. Okay? Now, the optics that they have you do for the MCAT, they're called spherical mirrors. And that's because they're based on spheres. Whoops. Meaning that you could have something like this or something like this, where if there's an overlap between the two spherical mirrors, you get this shape, which is a convex shape, right?
Okay.
Convex means it's fatter in the middle, and
Yeah.
and then this is called concave, which means it's thinner in the middle, right?
Convex is the real image, right?
What's up?
Convex is the one you see real images on.
Uh, we can get to that. So now, like, yeah, so the convex, and then this is concave, right? Right? Meaning, whoops, whoops. Like this shape
Mhm.
is concave, and this shape is convex, right? Okay. So now we're gonna look to see if something is converging or diverging, and that depends on if we're looking at um a convex or concave mirror or lens. So, for instance, if you had a convex mirror, the light rays that hit it, since a mirror is meant to reflect light, it'll reflect it at an angle away, right? So this is going to cause the light rays to diverge, right? Diverge meaning that they're spreading out,
Mhm.
they're moving away from each other. So this is a diverging mirror, which is going to have a convex shape, right? Right?
Yeah.
Okay. Now, if we had a, let's say, oops. Now, let's say that we have a convex lens. Since the purpose of a lens is for light to go through it, we will have, so let's draw these two light rays. The convex lens is going to be converging, meaning it's going to cause the light rays to move towards each other, right?
Right.
So
Mhm.
this will be a converging lens, which is also convex. So you can see that if you have a convex mirror, it's diverging. But if you have a convex lens, it's converging, coming together, right? Now, the other types of mirrors and lenses could be a concave mirror. Okay. Now, the light rays that hit, are going to be reflecting off and move towards one another, thereby making it converging, right? So now this is a converging mirror, which has a concave shape, okay? And now if you apply that to the lens,
It's gonna flip.
what's up?
I mean, the structure is gonna flip, right? It's gonna become a diverging.
Yeah, so now it will the light rays will move away from each other, thereby producing a diverging lens, right? So this is a whoops diverging lens, which is a concave shape. Okay. So basically, if you have either a convex mirror or a concave lens, they will both be diverging, right? And if you have a concave mirror or a convex lens, they will both be converging, right? So I can now bring these together by saying that if you have a diverging optical device, whether it's a lens or a mirror, so I'll say like in parentheses, could be a convex mirror or a concave lens, right? You
Yeah.
will always get, no matter what, something called SUV. What this means is the S means small, the U means upright, and the V means virtual image. Okay. So if you have a diverging optical device, whether it's a convex mirror or a concave lens, you will always, regardless of the object placement, you will always get a small upright virtual image. Now, I'm also going to throw in like the equations. Like for instance, there's the like thin lens equation. So let me see, I can write that here. So like, okay, 1 over focal length is equal to 1 over, so this O isn't 0, it just stands for object distance, plus 1 over I, which is image distance. Okay? And if you are diverging, you will have a focal length that's negative. Okay? This time I'll put like a dash in there to indicate 0. But you're gonna have if you have a negative focal length, it's gonna be a diverging optical device. And if it's a positive focal length, it'll be converging. And then also there's the magnification formula, which is negative image distance over object distance. Okay. And then for the magnification, if the magnification is less than 0, it's going to be an inverted image. But if it is greater than 0, it's an upright image, okay?
Yeah.
So those are the formulas. So now let's talk about converging. So converging optical devices will include either a convex lens or a concave mirror. Okay. Now, and then that would mean that your focal length is greater than 0, aka positive. Now, the type of image that's produced by a converging optical device will depend on the object distance. So I'm going to make like 3 columns, right? So I'm going to say this column is going to be object distance. This column is going to be image distance. And then this column is going to be the type of image that's produced. Okay. Oh, and then also let me do here, I'll do it over here. So let's say that we have our image, sorry, our whoops. Okay, so let's say that, yeah, this is our like, oops, like our lens, and we can, so I'm going to say that this is the focal length. This is 2 times the focal length. And then on the opposite side, this is the focal length, and this is 2 times the focal length. Okay, now I'm going to draw like a series of images, which I'm going to draw using like an arrow to indicate orientation. So let's say that I have, let me first make this a little longer. Okay, so now let's say that this is the image here. Sorry. Let's say this is the object. Okay. This up arrow is an
Yeah.
upright object that's that size, and its location is beyond 2F, right? So I could write this object location is greater than 2F, right? And if it's greater than 2F, your image distance is going to be between F and 2F. So I could write that the image distance is greater than F, but less than 2F. Okay. And this is something we can get from the thin lens equation up here, right? Because if you plug in for object distance to a number larger than 2F,
Mhm.
and you just do the math, you'll get an image distance that's between F and 2F. And from the magnification equation, you essentially have the image distance over the object distance. And since the image distance is smaller than the object distance, the magnification is going to be less than 1, right?
Yeah.
I should also say that for magnification that is equal to 1, it's just the same size. So now, so this type of image that's produced is going to be SIR. So the S stands for small, the I stands for inverted, and the R stands for real image. Okay? So this image that's produced is going to be like that right there. So you see how compared to the object, which is this up arrow here,
Mhm.
the image, which is the down arrow here, is inverted, which is why it's a down arrow.
Yeah.
And it's located between F and 2F, and it's smaller, right? Okay. Next, let's say that the object, we're just going to continue to make the object come closer. So if it was beyond 2F first, now let's say it is at 2F. Now this, I can put, whoops, right there. And this means that the image distance will also be 2F. And since magnification is going to then be 2F over 2F, which is 1, this is going to give you SSIR, which means same size inverted real image. So, and it's going to be at 2F. So now this is just going to be inverted like that at 2F, right? Maybe I'll use different colors here. So like blue,
Yeah. Yeah,
blue,
okay.
right? So you can see that compared to the black image arrow, it's the same size. I just moved it closer to the lens. And what that produced was an image that's both further and larger, right?
Yeah.
Okay. Now let's do, whoops, an image, same size, that is within between F and 2F. Okay. So now this is the next like row. So now let's say the object distance is between F and 2F. So just like when the image was between F and 2F,
Mhm.
object distance was beyond 2F, right?
Right.
So now this time, if the object distance is between F and 2F, the image distance will be beyond 2F, right? And you can see the pattern of as we go down, the
Yeah.
object distance gets smaller. And as we go down here, the image distance gets larger.
Right.
So now for this um, image, it's going to be beyond 2F, but this time larger. So this is going to produce LIR. What do you think this stands for?
Okay. Large.
And the I and the R?
You got it? You got it?
Good. Good, good, good. And that's this upside down green arrow over here, right?
Mhm.
All right. Next, what if the object distance is at F? Well, your image distance will have to be at infinity, but this really just means there's no image. Okay. And lastly, if the object distance is within the focal length, the image distance will be beyond 2F on the opposite side of where it's supposed to go. Now, this depends, right? Because
Yeah.
if it's a lens, we want the object to be on one side of the lens and the image to be on the other side of the lens, right?
Yeah.
So now for this, I'm gonna write like opposite, but that means just the opposite of where it's supposed to go. So in a lens, the image is supposed to go to the right. If the object is to the left of the lens, the image is supposed to be to the right of the lens, right? But this time it's going to be on the opposite side, so it's going to be on the same side as the object, but beyond 2f. So this is now going to produce LUV. What do you think this would stand for?
Large, uninverted, vectoral.
Good. So try the U part again.
Ooh, upright.
Upright. Good. So let me do another one like this, and I'll make this orange, and it's going to produce an image that is upright and larger and virtual. And you'll kind of see that as a pattern. Like
Yeah.
if it's an upright image, it's gonna tend to be virtual. If it's an inverted image, it'll tend to be real. So, and then you can see also the pattern of as the object distance gets smaller, the image uh, distance gets larger and the image size gets larger, and vice versa. So, so yeah, that's going to be the types of images that you get for a converging optical device. So to reiterate, if it's diverging, doesn't really matter where the object is, it'll always produce small, upright, virtual. But if it's a converging optical device, the type of image it produces will depend on the object's distance. And so we could see that if the object is beyond 2f, it'll make a small inverted real. If it's at 2f, it'll make a same size inverted real. If it's between f and 2f, it'll make a large inverted real. If it's at f, it'll make no image. And if it's within f, it'll make a large upright virtual. Right? Okay. Now let's talk about a context that this can show up in. So for instance, I'm gonna make okay, so I'm gonna just make okay, so this circle is a let's just say it's a regular eyeball. And a regular eye do you wear glasses or anything? No, right?
Mhm.
Okay.
Sometimes I do, sometimes I don't. Just
Okay.
especially
So
in the screen for too long.
got it. So a regular eyeball is around 2 centimeters long, and what happens and the lens of the eye is a converging lens. So let's say we have these two rays of light come in and converge. This part right there in the back of your eye is your retina. Okay. And that's a part in the back of your eye that has all the rods and the cones, and it's where the light is the real image is supposed to be projected on, and
Mhm.
your nerves, or rather like your optic nerve and stuff, can process that visual information. But you need the image to be projected right onto the retina. Okay.
Yeah.
Now, if we imagine the eyeball to be larger or longer, right? Like this, let's say larger than the 2 centimeter normal, you're going to have the same kind of thing happen with the light rays, but now, whoops. So now since the eyeball is longer though, they're going to converge sooner in front of the retina, like right there,
Mm.
right? And we want them to converge on the retina over here. So this is what happens when someone is nearsighted. And what it means to be nearsighted is it's easier for you to see something that's close up than far away.
That's myopia, right?
Myopia. Yep. So, how can we fix this?
Diverging lenses.
What's up?
Diverging lenses?
Yeah, very good. Because we want to, so if the lenses are converging too soon, we kind of want to delay that. So what we can do is we can throw in a diverging lens so that once the light rays, whoops, hit, they can diverge a bit so that when they hit the retina, they can converge on the retina where you want it to converge, right? And
Yeah.
that's how you correct for myopia. And so like I'm myopic, I'm nearsighted. So my glasses, the prescription is a negative number.
Okay.
And that's because up here you can see, right, that, oh wait, I didn't, oh, here I wrote it. So if it's over here, right, if
Mhm.
it's a diverging lens, the focal length is negative. Okay. So that's why my prescription is a negative number. I'll actually add that as well. So into this box over here. So I'll just write like, okay, your if your focal length is negative, this is um, diverging. If your focal length is positive, it's converging. And then lastly, 1 over F, if it is in meters, is the power, something called the power of your lens, and it's in something called diopters. So like my prescription is negative 2.75
Mm.
diopters,
Gotcha.
right? So now, yeah, so now that's your how to correct for myopia, and you can alternatively have an eyeball that is shorter, and that would be what?
Converging. You need converging lenses.
What's up?
You need converging lenses for that?
Yeah, and so this would be hyperopia, right?
Mm.
You're farsighted, your eyeball is too short. So
Mhm.
the image converges behind the retina. So
Mhm.
to fix that, we would use a converging lens so that once the light rays hit, they start they start to converge sooner and therefore will land right on the retina where you want it to land. Okay. So that's, yep.
Thanks. Yeah.
What's up?
This is making sense actually.
Yep, yep, yep. And now there's one more like eye like vision issue, and it's a little bit different. So like if you're nearsighted like me, my eyeball is longer than it should be. And if you're farsighted, your eyeball is shorter than it should be. But you know how like when people get older, they have a hard time like reading close up and stuff, so they need glasses.
Yeah.
But they could get those glasses from like a I don't know if you have like a CVS or Dwayne Reed or those types of places where you live.
Yeah, of course.
Yeah, so like like for me, I need to go to a doctor and get the prescription like glasses. But for like old people when they need like a reading glasses, they don't need to go to a doctor. They could just go to like a CVS or something and get them, right?
Mm,
So now what could cause someone who doesn't need glasses initially, which means that the length of their eye is exactly the length that it should be. Uh, what can cause them to later need glasses? So the part of your eye, or let me see if I can bring a picture up.
you think that's the muscle, like the
Yeah, yeah,
ciliary
yeah.
muscle?
Very good, very good.
Because I actually have glasses, but I don't need them.
Okay.
I only wear them when my eyes are strained at work because I'm looking at the computer all day.
Oh yeah, yeah. So that's why I have like because
Yeah,
there's like the program Flux.
no.
Oh yeah. You could like Google it. It's like F dot LUX. It's a
Okay.
thing that like automatically adjusts your screen based on what time of day it is. So like as the day gets like, uh as it gets later, it reduces the amount of blue light that your monitor is, shooting out and makes it more red light. And interestingly enough, like because we talk a lot about like in modern day like blue light blocking
Mhm.
glasses and stuff, right? But like originally, like seasonal affective disorder,
Yeah.
like when people like if they went like let's say you lived in California and then you moved to England,
Mm,
you're gonna feel depressed because there's not like it's not sunny.
yeah.
And that's because when blue light actually like blue light when it hits your retina, it
Mhm.
causes a reaction that starts to make serotonin, which serotonin, like improves
Mhm.
your mood, right? So like they would prescribe, but you could even like Google this, like blue light therapy. Like they can prescribe a blue like lamp or something that you look at, and when the blue light hits your eyes, it makes serotonin. So that's like a treatment for seasonal
So,
affective disorder. Yeah. Now the same thing, the serotonin that makes you happier, it also promotes wakefulness, which is why in, today's world with people using a lot of screens, even though it makes you happy, like if you look at it too long, especially if it's late at night, it makes you awake, so it makes it harder for you to fall asleep. So that's kind of like the ironic part about it. But um but yeah, I also have like my red like tinted glasses to make it so that even less of like the blue light can actually like, hit my eyes and stuff. But yeah, so what you were saying about the ciliary muscle is related to what's called presbyopia. So like when people get older, because okay, before you get older or whatever, if you look at something far away, your ciliary muscles will adjust to make it so that your lens is the right shape to focus on something that's far away.
Mhm.
When you then focus on something that's close up, your ciliary muscles will cause your lens to like get contracted or, relax in such a way as to be able
Yeah.
to focus on something close up. But when people get older, that muscle gets weakened and it's
Mm,
harder for them to do, it's called accommodation, where if you look at something close up, your eyes adjust for looking at something close up. So that's the people who can get those non-prescription glasses from like a CVS or something. So that's pretty much, yeah, pretty much optics and the um medical contexts that they can come up in, as well as the formulas associated with them. and the type of images that they can produce. Um, and yeah, that's yeah. What do you think so far?
Really good. Is there a way I can get this slides so I can play with them?
Yeah.
Mm.
So on the left, I'm gonna call this.
Or do I just screenshot it?
Oh no. So on the top left, does it say?
Yeah.
Do you see where it should say Victor Session One Optics?
Oh yeah, yeah, it does that.
There's the three like horizontal lines.
Hmm.
If you click that, it'll open up a drop down.
Hmm.
And is there an export option?
Hmm.
Like when you hit the drop, like when the drop down menu comes down, like what is it? What options does it give you?
Gives me if I want to rename it, if I want to view it. I don't see export though.
Oh, okay. Let me see if I can do that. Okay, I'll just export it myself and I'm gonna put it in the chat. Oops. All right, I put the PDF in the chat. See if you
Yeah,
could get it downloaded that way.
well, I got it. Thank you.
Yep. I'm gonna use the bathroom real quick. I'll be right back. All right. What would you like to go over now?
Um, I think one of my fundamental problems is when I'm reading, especially like science passages, I can like keep track of things, you know, and also the logic behind things. I don't know if there's a strategy for that, or if we can do maybe one passage, one science passage, and maybe one cars. That would be really helpful.
Yeah, did you say for a science passage or like a cars passage? Like
Now, I mean, do we have time for both?
we
For
could.
one each?
Yeah. Let's see.
Okay.
Could do so do you have like the AMC like material like
Yeah, I
sec
have a lot.
the section banks and stuff?
Yeah, I do.
Okay. Let's have you open up the section bank volume 1.
Okay.
You could you could share your screen. I can kind of like walk you through that as well.
Okay.
Oh yeah, you did pretty well on this.
Actually, it took me a long time to get there.
I see,
Like
I see.
just sitting there. I didn't like pick it up instantly. I was just sitting there, just
Mm,
thinking because I didn't want to get the answer. So it took me a long time.
got it, got it. All right, let's have you like up here go to the section bank and we'll start with like a science section. So yeah, you can hit that too.
Okay.
And section bank volume 1. Yep. And let's start with BB.
Okay.
Mhm. Yeah,
With Jack
open
Westin.
Jack Westin, yeah. All right, so let's see. Um, so the strategy I'm going to show you is going to involve writing proportionalities. So you might see like other people do something like, okay, if A goes up, B goes down, stuff like that.
Yeah.
But we're not going to do it that way. We're going to do it mathematically. So I guess I'll show you that as you read through this. So yeah, why don't you start off by reading? So now there's going to be things that I call buzzwords, which are words that um so like all these like passages are from like published papers from like PhDs and doctorates and stuff. So we're not expected to know it to that level. What we
Okay.
are expected to know are like the more basic science aspects of it. So yeah, so you can start by reading it and I'll kind of let you know like what some examples of the buzzwords can be.
Okay.
Mhm.
So it says blood flow to the brain is regulated by changes in arterial vessels diameter in response to intravascular pressure, process called myogenic response, MR. The MR allows cerebral resistance vessel to achieve a state of partial constriction, form which they can dilate or further constrict to alter blood flow.
All right, so they're kind of giving us some information by saying that you can regulate blood flow to the brain um, uh, by changing arterial vessel diameter, um, and then they can dilate or constrict further. Okay, you can continue.
Okay. Vascular smooth muscle VSM contraction is initiated by cell membrane depletion, which opens voltage-gated calcium channels. Calcium ion binds the cytosolic protein palmotine, which activates an enzyme that phosphorylates amino acid residue maintained of the myosin light chain LC20. Phosphorylation of LC20 is required to activate the myosin head, which binds to actin. This myosin-actin interaction forms the basis of the cross-bridge cycle (CBC), which causes muscle contraction as in skeletal muscle.
Okay, so so now they're saying that this VSM contraction is initiated by cell membrane depolarization, which opens calcium channels. So I'm going to write something like um, VSM contraction. Now, if something one second. Okay, so so like let's say if A goes up and B goes up, and I were to graph this, it would look like that, right?
Yeah.
So we're gonna write, instead of the arrow thing, we're gonna write it. So this is the proportionality symbol, and it's gonna be A is proportional to B. Okay.
Yeah, that makes sense.
Now, the thing is that if A goes up and B goes down, what do
I'll
you
be at
think this
inverse.
would look like?
I'll be at inverse.
Like
Uh,
that?
yes.
Okay. Now, the thing is that this is supposed to be like this. A is proportional to 1 over B. That's the proper way of writing it.
Mhm.
And when you write this, what number can B not be?
So B can be higher than A.
So just think
B,
about in any like fraction, what number can the denominator never be?
was zero.
What's that?
Zero?
Correct. It'll be undefined, right? So
Mm,
this is actually going to look like this, because if you think about it, like if A goes up, B goes, or 1 over B goes down. But let's say A is like 2000, this will just be 1 over 2000. So as A goes up, B goes down, but it never hits 0. It can go down infinitely. Like let's
mm,
say that you walk to like your door, okay? And let's
mhm.
say every step you take, the next step must be 1/2 of the previous step. Will you ever reach your door?
No,
No, right? So what
no,
this means is, do you remember what asymptotes were?
no.
So they're imaginary lines that something can infinitely approach but never touch. So there's
So,
going to be asymptotes at the axes, and this will look like that. Okay.
like a
So, uh,
cloud?
yeah. So, like a direct proportion will look like this. An inverse proportion may seem like it looks like this, but it really looks like this. Okay. And this is something that they like to ask. So let's make sure we know that an inverse proportion is this, it's a hyperbolic curve. Okay. And so that's why we're going to do it everything in terms of proportionality rather than arrows. So VSM contraction is initiated by depolarization. So I'm going to say this is proportional to depolarization, right? And they say that depolarization opens voltage-gated calcium channels. So I'm going to say this is proportional to the calcium channels opening. And then they say that the calcium ions can bind to the cytosolic protein calmodulin. So I'll say proportional to um, calmodulin, like binding, which activates an enzyme that phosphorylates amino acid residue 19 of the myosin light chain LC20. So I'm going to say this is proportional to, I'm just going to draw like a P with the circle around it, which means in my head like phosphorylation of LC20. And when LC20 gets phosphorylated, it can activate the myosin head, which binds to actin. So now I'm going to say this is proportional to myosin binding to actin, like that. And this myosin actin interaction forms the basis of the cross bridge cycle, CBC, which causes the muscle contraction. So this is proportional to CBC, which is proportional to contraction, right?
Gotcha.
So now I can link all of these together. I can say
So,
that if we have, so let's say, let me ask you this, like, what if we blocked the calcium channels from opening? What would be the impact of that?
Rocket, there'll be no modeling, and there'll be some active interaction, so contraction.
What's up?
So there will be no modeling binding
Hmm.
to calcium 20, so no muscle contraction because there's no myosin actin interaction.
So are you saying there will be or won't be muscle contraction? Not be. Good, good. Um, will you have phosphorylation of LC20 if you don't if you close if you have the calcium channels closed?
No, I don't think so.
Correct. So that's how this all relates to each other. And we don't even like honestly like we don't even necessarily have to know like the specifics of what calmodulin even is really because we could just connect it to all these other things. Okay?
Yeah.
All right. Yep, continue to the next paragraph.
Okay. Dynamic reorganization of the actin cytoskeleton occurs during VSM contraction and relaxation. During actin polymerization, monomers of actin, G-actin, polymerize into filamentous actin, F-actin. Actin depolymerization can be induced by the drug lactose coaling.
Okay. So so they're saying that when the VSM contraction happens, or I guess also if it gets relaxed, you can have some reorganization of actin, and we kind of see like kind of two things that can happen. We can have actin polymerize, in which case you have more F actin or G actin.
Okay.
What's up?
Yeah, that makes sense.
Oh, so if you have actin polymerization happen, will you have more G actin or F actin?
During actin polymerization, we get more G-actin.
Are you sure?
It says during actin polymerization,
Yep.
monomers of actin of G-actin polymerize into. Oh yeah, we'll get more of the F-actin.
Good. So I could add to this VSM contraction is proportional to F actin, and which means we're gonna have more F actin, right?
Yeah.
And less G actin, right?
Mhm.
So I can put that as an inverse proportion down here. So now I can see that if I have VSM contraction, I will have more F actin and less G actin, right?
This math is incredible.
Right.
It makes sense. Yeah.
Okay, now
But
lat.
can you make that speculation that jump though? If
Wait,
I
what's
know
up?
you say that during polymerization, we're gonna get more F actin, but can you jump to the fact that there's also gonna be lower levels of G actin?
Yeah, because it says during actin polymerization that monomers of G actin polymerize into F actin, right?
Okay.
So we know that if polymerization is happening, like what is polymerization?
Making something plenty, I suppose.
Making something what?
Plenty, like
Oh, you said plenty?
yeah,
Like more so monomer means one like unit of something, right?
yeah,
And then a polymer means more than one unit, right?
right.
So if you're polymerizing something, the number of monomers should go down, right? and the number of the polymer should go up.
Yeah, of course.
So
Yeah.
they're saying that G-actin is a monomer. If we polymerize that, it should be less of that, right?
Yeah.
And if they're saying it polymerizes into F-actin, then that means we should have more of that, right?
Yeah.
So there's nothing intrinsic about G-actin or F-actin that we need to know. Like we're not expected to know that F-actin is the polymerized type and G-actin is the monomer type. Like we're not expected to know that off like, from our memory,
Mhm.
but we can know that because they're telling us that when actin gets polymerized, the monomers of G-actin turn into the polymer of F-actin, right?
That makes sense.
Okay. Now it also says here actin depolymerization, right? So that's the other way around, right?
Mhm.
And so if polymerization means more F-actin, depolymerization would mean more what?
That means that means G acting on the other side.
You said that means G-actin is gonna what?
Uh, then we're going to reverse it. It's going to be an inverse.
So
So
yeah.
depolarization is going to be more F acting and lesser G acting.
Sorry. So during the polymerization, you have more F or G.
You have more F.
Okay. What about during depolymerization?
You're going to have the more F. So you're going to have lower F as
So more.
as opposed to
Mhm.
G.
Okay. So if you are polymerizing, are you gonna have more F or G?
If you're polymerizing, you're going to have more F.
And if you depolymerize,
You're going to have more F and more G.
more G then, right?
Yeah,
And what can cause the depolymerization?
the drug.
This, right? So now I'm
Yeah,
gonna write lat B is proportional to G actin over F actin, right?
that makes sense.
So if you have vascular muscles, vascular smooth muscle contraction, you'll
Mhm.
have a larger amount of F actin and a smaller amount of G actin, right?
Yeah,
And if you have the drug lat B, you're going to have more of the G actin, less of the F actin.
correct.
So lat B, it could also be inversely proportional to VSM contraction, right?
Yes,
And
inversely.
also inversely proportional to depolarization, inversely proportional to calcium channels opening, so calcium channels closing, right? So lat B means you're going to have less calmodulin binding, right? Less phosphorylation of LC20, less of a cross bridge cycle, less of a contraction, right? Everything comes full circle, right?
Right,
Because this contraction is this contraction, right?
that makes sense.
So we see how we connected all this together.
Yeah,
And we don't even really need to know specifically what this stuff is, right? For the most part, at least.
yeah.
So,
Okay.
yep. All right. You can, yep, continue.
All right. To examine changes that occur in VSM during the MR, researchers expose isolated white cellular bodies, MCA, to increasing internal pressure to intravascular changes that will occur in vivo. Arterial diameter and the amount of phosphorylation phosphorylation of component reduces its inhibition of the actin-activated myosin and GATPase. And G-actin were determined response to a three-step pressurization from 10 to EV to 120. Table 1.
Okay. So they are now describing an experiment and they are exposing you know, rat arteries to increasing pressure. And then they're measuring things like the arterial diameter, the percent of phosphorylated LC20, the percent of phosphorylated calponin, um, and the amount of G actin. So, what could be our what could be our independent variable and our um, dependent variable?
I think the dependent will be the changes are occurring via ML, because that's what the
So these stuff, right?
yeah,
Because this stuff changes, right? But the change in pressure could be the independent variable, right?
right.
Because the change in pressure, like we're just increasing the pressure from here to here, right? But the subsequent changes in arterial diameter and phosphorylated LC20 and stuff will depend on that independent variable of pressure, right?
Right.
So now we can just kind of look at the relationship between the dependent variables with pressure. So I'm going to just write pressure is proportional to. So if we increase pressure going this way, what happens to the arterial diameter?
I think it's decreasing.
So I could write 1 over arterial diameter, right? Because it's an inverse proportion, meaning if pressure goes up,
Mhm.
arterial diameter goes down, right? Okay. What about phosphorylated LC20?
That would be proportional.
What's up?
Pressure is proportional to
Good. So I could say proportional to LC20. And then what about phosphorylated calponin?
proportional as well.
All right. So I'll just write like, oh, I forgot to put, so P with the circle. Oops. Like that's just a way for me to write that something gets phosphorylated, which, by the way, like is an important thing, which we'll talk about in a bit. But like things getting phosphorylated and stuff like are gonna be on the test like all the time. So I'll just write P with a circle and then like calponin. And what about G-actin?
G actin is going to be
Inverse, right?
yeah,
Which would mean that it should be proportional to F-actin, right?
yes.
Because G-actin and F-actin are inverses. You can't have more F-actin without
Mhm.
losing G-actin and vice versa. So I'm going to say F-actin over G-actin. So we see that here, if the as we increase the pressure, the G-actin decreases, which means the F-actin must increase, right?
Yeah,
All right. So I'll let you take a screenshot of this. Do you know how to take a screenshot?
yeah, yeah.
All right. So then you get like, the proportionality relationships down.
Can I use this method with like other passages as well, or
Yep.
it's passage specific?
Yep. You could use this for everything. Like honestly, like I even use it for stocks. Like for instance, uh if a stock price goes up,
Hmm.
or rather, if the stock market goes down, the price of gold goes up.
Yeah.
So I could say stock price is inversely proportional to gold price. Because if the stocks go down, people hedge on gold. But also, like let's say gold and stocks go down, then Bitcoin can go up. So I could say it's also inversely proportional to Bitcoin. So I could use this the idea of seeing things in terms of proportions. Not only can you use it for other types of passages, you could use it for all sorts of things in life.
That is true.
Mhm. So so yeah, you could use it for all sorts of things. And
Okay.
really, but the reason I wanted to show it to you in BB is because in BB I think it's the most useful because in BB you have a lot of acronyms, right? You have like over here you have VSM, right? You have like LC20, you have CBC, you have G-actin. So many, it's hard, like it's pretty much impossible to be able to keep track of all of this in your head.
Mm-hmm.
Why we write out the proportionalities because then we can like equate them. Okay.
Yeah, that makes sense.
So for this question here, let's try this question out.
So it says, based on the information in the passage, which type of enzyme is most likely to suppress CBC? So we're suppressing CBC.
Okay.
That's the
So
question.
let's first think about what would like stimulate CBC.
So if we go according to the map,
Hmm.
CBC, we're going to have depolarization. That's going to be two causal channels open that we call one and phosphorylation and minus a active interaction. So in
Okay.
that,
Yep.
so if we're going to if we're going to like suppress CBC, then we have to go in the inverse order.
Okay.
Well, I'm thinking C, because phosphatase is something that takes phosphate out.
Yeah, look at you. So you see here, right? That yeah, a lot of these things cause CBC, but one of them is this, right? The
Yeah.
phosphorylation of LC20.
Mhm.
So if you want to suppress CBC, you would want to not phosphorylate LC20, right? And that's why you chose C, right?
That's correct.
Yep. Now, a little bit about the other stuff. Now, um, so okay. So a phosphatase removes phosphates, a phosphorylase adds phosphates, but a kinase, this is something that's very high yield, is technically a transferase, which means it can both add and remove phosphates. Okay?
Mhm. Chemist is always add phosphate.
Yeah. So the thing, so now this is like the most high yield enzyme. So I want you to know that. So for instance, right,
Mhm.
glycolysis, you have like hexokinase, and that phosphorylates glucose into glucose 6 phosphate, right?
Mhm.
Now you need to know that for kinases, what they do is they use S, T, or Y. What are these?
Serine, tyrosine,
And
tyrosine.
and
The Y, tyrosine.
so what's the T?
Three of them.
Yes. What do they all have in common?
Mm. So, so hydrophilic,
Do they
hydro-
wrote?
hydrophilic amino acids, and they can be phosphorylated as well. And
So what I just drew over here,
yeah,
what I draw?
uh, It means they can be phosphorylated because they have the OH group.
So they all have the OH group, right? So now this is going to be the most common nucleophile on the test. So I want you to train your brain whenever you see a hydroxyl group to think nucleophile. Okay?
Got it.
Because
Mhm.
it's going to come up all the time. Now, the most common electrophile is going to be a carbonyl group, which is a carbon double bonded to an oxygen. Okay? So usually this is going to attack that, right?
Mhm.
So now, just like the carbonyl group has a partial positive here, partial negative, a phosphate is similar, right?
Right.
In that it has a bunch of oxygens pulling electron density away. So it can also attack a phosphate. And that's what it does in a kinase. A kinase is going to take a phosphate from
Mhm.
ATP. So let's say this is the adenine. You have the three phosphates, right? For ATP.
Yeah.
Now, we can number them using Greek letters. So the closest phosphate to the adenine is alpha, followed by beta, followed by gamma. Okay? So
Mhm.
a kinase, if it takes a phosphate from ATP, it's going to take the outermost phosphate, which is the gamma phosphate,
Gotcha.
and it can give it to a substrate, like let's say glucose, to give it to turn it into glucose 6 phosphate.
Mhm.
Now, it could also do the opposite. So the third irreverse or the last step in glycolysis is pyruvate kinase. And that takes PEP phosphoenol pyruvate into pyruvate, right?
Mhm.
But this time it removes the phosphate, right? From PEP to pyruvate, you're removing a phosphate.
Right.
And you're giving it this time to ADP to make ATP. So you could see how a kinase can either take a phosphate from ATP to give it to something, or it can take a phosphate from something and give it to ADP to make ATP.
That's true.
Okay?
Yeah. That makes sense.
Yeah. So now this all this stuff is gonna definitely be, on your test and everything. So definitely good to know it. But yeah, you're right. It's gonna be your phosphatase here. Good job.
Yeah, that makes sense.
Okay.
And number two said, which statement regarding VSM function and cytoskeleton dynamics is best supported by the data in table one? So we're looking at VSM. And okay, so let's see. Vasoconstriction is associated with an increase in the ratio of F-actin to G-actin. Vasoconstriction, we see that that might be the case. There's an increase because according to you know the map, it says that there's going to be more F-actin as opposed to G-actin. But I'll just go down. The F-actin levels decreases as phosphorylation of calcium increases. It doesn't decrease.
Okay.
Vasodilation does not affect phosphorylation levels of carbon. I think it does because if you look at table, definitely changes. Like the numbers are not like static. So
Mm-hmm.
is my logic correct or not?
Mm-hmm.
Um, the arterial diameter reduction is always dependent upon increased component phosphorylation. Component I don't really understand that is dilation of VSM reduction is always dependent on increased component phosphor. I, I don't know if I'm just running away from D, but I'll just take A because it looks a little bit easier.
So there's
Uh,
a word in D that makes it not that good.
it's always, you said,
Uh-huh.
is that it? Yeah.
Yeah, because so they're saying arterial diameter reduction,
Mhm.
that's this, right?
Yeah,
And it says always dependent on increased calponin phosphorylation, which we see here, right?
yeah,
Now, if we're going from 21, or sorry, if we're going from this to this, we do see an increase in calponin phosphorylation, right?
yeah.
But when we go from here to here, we do not see an increase,
That
right?
is true.
So this is wrong because it says always. And you
That
want to
is
be you want to always on the lookout for extreme words like that.
true.
And how do you know if it's extreme? If you assign a percentage to it,
Yeah.
always will be what percent?
Always like 100% or something.
Yep. And is so like 100%? Like, yeah, no, not from here to here, right? But you see that vasoconstriction is associated with an increase in the ratio of F actin to G actin, and we see that vasoconstriction here, the
Yeah.
amount of G actin goes down, which means the amount of F actin goes up.
Okay.
And there you go. So see how we answered this by using our proportionality relationships.
Oh, that makes sense. Yeah.
Mhm.
Second language.
Yep.
Let's go. All right. So the next one, compared to control, RMCA held at internal pressure of 120, application of nitrosamine to RMCA held at 120 is likely to result in. uh, So we're looking at internal pressure of 120 compared uh, to controls, right? I know this drug actually inhibits stuff, so it's probably going to increase phosphorylation. It, it decrease to I'll go with D, C, because the drug actually, what the drug does is to, just like your map said here, it's going to be more G actin as opposed to F actin.
Yep. There you go.
It took me a second there.
Mhm. Yeah, because they're trying to be they're always going to try to like confuse you here with extra
Yeah,
information, right? Because they're saying that they're holding it at 120 and they expect you to look at that, but they're really just saying that we're not changing the pressure, but what we're
yeah,
doing now is we're adding lat B, and we know lat B produces less F actin And we know if you have less F-actin, you must have more G-actin. So, yep, it'll be C.
Yeah, cool. Oh, according to the information in the passage, which statement best describes the function of the MR in response to stimulation of the sympathetic nervous system? And sympathetic nervous system will be uh, flight response. So I'm looking for something that's going to blood pressure, stuff like that. Equalizes blood pressure in cerebral resistance arteries in the aorta. Motivates blood flow to the brain under high pressure. I don't think it equalizes. Like, it didn't say anything about equalizes means equilibrium, right? Like something that's in a state of like equilibrium, right?
This is just saying that the blood pressure in the aorta is the same as that in the arteries in the brain.
Okay. I don't think Emma did that because it said
Yeah, because the aorta should be the high where the blood pressure is the highest, right? Because that's where it pumps
right.
out of your heart.
Mhm.
So everything else must have a smaller blood pressure, right?
Right.
Okay.
Uh, then C enables cerebral resistance.
What did you think about B?
I'm gonna keep B for now and see which
Okay.
one
Yep,
will kick
yep.
it out.
Okay.
Um, cerebral resistance artery to locally vasodilate, arteries to dilate. Okay, to the brain under high pressure. Cerebral resistance person to achieve a state of partial restriction. I think I'm gonna knock out C.
Hmm.
Redirect blood circulating in the, to organs in the abdominal cavity. This didn't it didn't talk about abdominal cavity, but
Hmm.
I'm gonna keep B.
Yep.
Yeah,
Hmm. Yeah, so D would be something that would happen in the parasympathetic nervous system, but also
yeah.
they're asking us about blood flow in the brain, so we need our answer to include that. Yep.
All right.
Hmm.
Polymerization of which structural component was analyzed in the experiment described in the passage. I remember they said something about polymerization. During actin polymerization, and I know actin is affiliated with
Hmm.
yeah, microtubules will be
The
dilated,
myosin.
right?
The myosin.
Yeah, the myosin, okay.
Mhm.
Yeah, so I choose
Yep.
microtubules. What is like the structure of the amino acids found at position 19 of the LC20? So if I go to the passage LC20, I'm looking for an amino acid that's phosphorylated, which activates an enzyme that phosphorylates uh, amino acid residue at 19 of the myosin-like chain. So I'm looking for an amino acid that's phosphorylated, which is D.
Yep.
Right?
Yep. Because remember we talked about STY,
Yeah,
OH group. So you see
yeah,
how like when people say like memorize the amino acids and stuff, like it's not as useful as being able to see why things happen. And we talked about why, like, remember when I said STY
Hmm.
and you were saying like they're phosphorylatable, but then my question was what makes them phosphorylatable? And it's the fact that they have OH groups. And now here in the answer, this is the only one that has an OH group, right?
Right.
So there you go.
Do you think this passage is relatively easier, or is it because of the math?
Uh, it's likely because of the proportionality relationships that we made. Yeah, the map. Because that means that we just know that when something goes up, something goes down, something goes up, something goes up, and we answered most of the questions based on that. Yeah.
Okay.
So,
Because sometimes, like when I'm going through passages, like
mhm.
I lost track of things. Like,
Yep. So this helps us yeah, keep track of everything.
yeah, this really makes sense.
Yep, yep. So yeah, so we're gonna have to wrap up because we did did like like a little bit over the 2 hours, but we could meet some other time like this week to go over like cars and stuff. So
Okay. How
um
would you like to get to?
oh yeah, you have Zell, right?
I do have zero, yes.
So this is my phone number. I put it in the chat. And yeah, it should be 160.
Okay. Okay. Uh, do you think
Mhm.
if I push my test back, it's really gonna affect like my timeline wise?
If you're applying this cycle, it'll like hurt that, but if you give yourself more time, it would probably increase your score. So I think you would have to think about like the cost benefit of that.
Yeah, Venmo.
If you have Zell, that would be better.
Yeah, one second. Okay. Chime, so I don't know if Chime has the school first, they always have Zelle, but I moved to a different state and everything changes.
Should be like through your bank, right?
And this is your phone number, right?
Oh yeah, 917-293-5994.
917-293-5994.
Yep.
All right. I'm gonna go use my wife's phone number and send it to you right now.
Okay.
And then because I work from the office Tuesday, Wednesday, Thursdays,
Mm-hmm.
do you have I looked at your calendar, it looks like you have time between Mondays because the best time for us to move is Mondays and Fridays.
Mm-hmm.
And Saturdays will be the day that I'll take like the full day, right?
Yep. We could do that.
Okay.
Mm-hmm.
Um, so I think probably Mondays will be
Okay.
best. Maybe like 2 hours. Does that
Yep.
work?
Yeah. And you could use the Calendly link to set it up for the
Like a
days,
brain
right?
thing? Yeah.
Or I
Yeah.
can like just put you in manually. It's up to you.
Yeah. Okay. I'll
Mm-hmm.
take it. My phone number. in your experience, right? Like your experience, like teaching. I know you have to go do other stuff, but
Hmm.
within the timeline that I have you seen like someone improve, like within the limited time that I have to at
Yeah.
least about 10?
We could see based on like your like the how you do on like practice tests
Mhm.
and after you do like that content diagnostic to make sure we get all that content down.
Right.
But yeah, we'll see like where you're at um in terms of like the practice tests and stuff.
Okay. All right. You got my phone number? I'm gonna
Oh, what
send
is
the
it?
cash right now.
Hmm.
I have to use my wife's phone. So
Sure.
all right. I'll text you when I get it done.
Okay. And you're gonna send it through Zelle?
Yeah, 160, right?
Yep.
All right. I'll send it right now.
All right then. So yeah, and then I sent you the link for Calendly, right?
Oh, wait a second. Okay, I saw two emails from, okay, pretty positron for spreadsheet. Those are the two emails I got.
Oh, sorry. So here, I just sent another one.
Okay. Not here yet. Maybe I should be using Gmail.
Oh yeah.
I
Hmm.
have a Gmail, but it's still the same name, the same everything, but just Gmail at the end.
Okay.
Still not here yet. Okay, got it. See you now. All right.
The Calendly link.
Yeah. Got
Okay.
it. All right. I'll take care of it.
Okay. Yeah, so you can use the Calendly to sign up for like the next sessions and you'll send me the Zelle.
Yes, I'll send it right now.
Okay then. All right. Pleasure meeting you. And yeah, we're gonna crush it.
Nice to meet you too. I really learned a lot today.
Yep.
So my thing is just to make sure that I know what I'm doing. Like
Hmm.
I know how to like tackle those classes,
Yep.
and also to be able to map. Maybe in our next session we'll talk about timing as well.
Yep. Yep. All right,
All
totally. All right.
right.
Great meeting you. I will see you soon, okay?
I'll see you soon.
All right, take care.